Okay, so here we have some calculations using right-angled triangles, and again I have my tools, which is my SOHCAHTOA acronym. Okay, by the end of this video I want you guys to feel like exterminators, because I want you to be killing the rats. So they say here in triangle ABC, angle B is 60.5 degrees, AD is 18.2 centimeters, and DC is 9.7 centimeters. Right, I don't care about the questions yet. What I do care about is the fact that there's a 90 over here, and because BC is what appears to be a straight line, we have another 90 over here, because angles on a straight line need to add up to 180. Okay, we have two rats identifiable here. We have this rat, so let's just call this rat 1, and then we also have this rat. Let's call that rat 2. And because you have two rats, you have trig ratios and Pythagoras at your disposal in two places. Okay, so now the questions read to calculate the length of AC, which is this guy over here. Calculate the length of AC, then calculate the size of angle ACD, which is down here, and then finally the length of BD. Okay, AC. AC is in rat number 1, and AC is also the hypotenuse of rat number 1. And so AC is just a matter of Pythagoras, and so therefore AC is going to be the square root of 18.2 squared plus the 9.7 squared. And of course I'm doing this because I am making use of Pythagoras law. And once you type this in your calculator, you should find that AC is equal to 20.62 units. Okay, now I realize that I might have confused somebody by going straight into this step. So let's say AC squared is going to be AD squared plus CD squared, and then from here you could have just substituted those values. So AD is 18.2 and DC is 9.7, right? And then from here you would have just put that value under your surd. Okay, all I did was bypass these two steps and go straight to that step. But if you want to write everything out, that is totally fine. And so the length of AC is 20.62 units. I can almost guarantee you that if you don't write down the things that you find on your sketch, you will feel stuck at some point, because it will feel like information is missing even though you already found some of the information. Okay, so next we have to find ACD. ACD is the angle in the bottom left encircled in black here. Okay, and that is an angle within a rat, but also within a triangle as a whole. Okay, this angle C plus this 90 plus this missing angle will add up to 180. So that's one of your options, but that's not feasible because you don't have this angle yet. But angle C is also with the 60.5 and with angle A, but again you don't have angle A, and so using the interior angles of a triangle is not the way to go here. Instead, we need to use rat number 1, okay, and make use of our trig ratios to find angle C. So at the start they gave us the opposite and the adjacent, right? So what you want is angle C. What you have is the opposite, the adjacent, and the hypotenuse. But I would say, just in case your hypotenuse is wrong, use the ones that they gave you, which is the opposite and the adjacent. So now what can you do, or what can you use? You need to use tangent. And so we now can say that tangent of angle C is the opposite over the adjacent, which is 18.2 over the 9.7. At this point, we now have to just solve for angle C, and so therefore angle C would be arctan of 18.2 over the 9.7, which gives us an answer of 61.94 degrees for angle C. Right, so I would write that in as 61.94 degrees. Okay, lastly is to find the length of BD. Now there are two options here, and I'm going to show you the easiest one, or what I think to be the easiest one. So let's take a minute to check what we are working with. We want to find BD, the rainbow side, okay, and BD is in rat number 2, so let's just work in rat number 2 for a moment, and let's ask ourselves the question, what do we have? We have the opposite, right, the 18.2. What do we want? Well, we would like to find the adjacent, which is BD, right? So now what can we use that has opposite and adjacent? Well, seems like tangent is the one again, so we need to make use of tangent. So we start off by saying that tan of 60.5 degrees is the opposite side, 18.2 over the adjacent side, which is BD, right? Now again, we use our triangle to help us out a bit. So we have the tangent 60.5 over here, we have the 18.2, and we have BD. Okay, so to get BD, we say 18.2 divided by tangent of 60.5, and this works out to give us 10.297, which we can simplify as 10.30 units. Okay, and that is the length of BD, done and dusted. Okay, now I will tell you what the alternative was, but I won't work this one out. You could have worked in the big rat, okay, could have worked in the big one because you had this angle C. So you could have used these two angles, okay, and then found the value of this angle, right? And then you could have used angle A to find the entire hypotenuse and then subtract 9.7 from it. Okay, so that's your second option. I think that any option besides the one I just did is very extensive and time wasting, and so I would prefer if you just go with the easiest option. So my fellow exterminators, if you want to sort out any rats, you need at least two things, only two things. With those two things, you can find the third thing. So you either have two sides, you can use that to find the third side, or you have two angles, which you can use to find another angle, or you have one angle and a side, which you can use to find another side. So you just need two things, and we had those two things at the end. In 323, we had 60.5 and we had 18.2, and we could use that to find the missing side BD.